We're going to continue with the implementation of our reinsurance pricing framework. And before we go into the modeling, we will start with the underlying data structure. We'll start with analyzing the data structure of conventional pricing models. These models have certain shortcomings and they are incoherent, and the goal is to come up with a refined approach. We will analyze the shortcomings of the conventional model and we will discuss the needs which we have to fulfill, and we'll step by step then transition and introduce a new model which is covering the needs of the pricing framework which we're going to implement in the MeshWeaver platform. Welcome back to the MeshWeaver channel. Our job is to help you to manage and understand your data. My name is Stefan, I'm here with Roland, and today we will look into the data models used for implementing pricing tools in reinsurance. And just to remind us, what I have designed here is a small chart to tell where we are. So we are looking into this generative model. The idea is, once we have this model, we want to use it for two different purposes. On one hand side, you want to use it retrospectively, and we want to calibrate our model, so we will generate claims for the past observation period, 10, 20 years, depending how much information we have. We will compare it with the actual claims and then use these calibration parameters to project the model to the future, and then we can run it for pricing purpose. So this is basically what we want to accomplish, right? And so today we will stay in the top box here, so in this generative model, we will then move forward and then eventually cover everything, but this is done step by step. What I have here is just a very simple extract of what we're presenting today. So it's an entity relationship model, very simplified. We have exposure, we have model, and we generate claims. That's basically what we want to do. We will then see, to get there, we need to maybe start in a place where people are familiar with, and then we will see what exactly do we need to modify and change so that we can use it in this context here. I call this the conventional exposure-based models. So they have already several entities which you can see here, but it's not that complicated as maybe it looks at the first sight. So if we go down here, there's not much left here in the bottom of the screen, so we can skip this part. So the most important thing is in the center, we have an exposure profile. And the profile has overall attributes. You say, in which year do you have this exposure? What is the line of business which is covered? What is the category maybe of risk? Where are the risks located? Maybe which currency, which units you are using. So this is some information which you would typically host here in an entity which is describing the profile as a whole. And then you have multiple bands. So you can see this in a one-to-many relationships. You can have multiple exposure bands, and each band has an upper limit and an upper and a lower and an upper limit. So to and from, you specify how many risks you have in there. Maybe you say what is the average size of the risks. Maybe you have some premium rates which you can use to translate the exposure into a premium, and then if you want to go the next step and also to say what is the expected loss, then you come up with a loss ratio, which of course you can put in there, and then you derive the losses, or you can enter it into the model, and then you don't really need it. But let's assume we don't have the information, so we take the loss ratio from a market, as the experience, and we put it into the bands. Now, the important next step is, typically, once you have such a profile, you connect it to your model. And the model needs three parts. One is the frequency, so you have to say how many claims do we expect in a certain period. Then you have the severity, so you want to know what is the range of the size of the claims that you have. Assume we're talking about the ultimate loss, which we have for a claim. And then, of course, what's also important, especially in long-tail business, is then the development of the claims. So normally you have claims are reported with some delay, so you have a reporting lag. It takes, depending on the line of business, 10, 20 years until a claim is closed, so you have a closure lag. And in between, you have then payments, and you have also an assessment of the ultimate, which you do down the road. So maybe the initial estimate is too low, then you have some adverse development until you end up with the ultimate, or in other cases it's too high, and then you have a favorable development. So this is everything which is in the development. So somehow you have to go and connect this model to your profile. And once you have it, you can run it and you can generate claims. And of course, the claims have then also some attributes. And here I've attached or connected the incurred pattern and the paid pattern. So this is the generic setup which we have. Now, in my view, this approach works if you have very good information about which model you have to use for a band. But this is not always the case. And then the question is, when it's very flexible, you connect the model to each band. And what could happen is then you have certainly some inconsistencies between the different bands, or the model in different bands. You can also model frequency, severity, and development kind of independence. You have a lot of flexibility, but it's incoherent. And this is, in my view, one of the big challenges in this approach. So you need a lot of expertise to run such a model, right? And you have to do it not off period, but you have to do it during the renewal. When you get the submission, then you have to come up and put all these components into your tool. Now there is, of course, you can say, yes, we have, if you operate in a certain market, we know which curve we need to use, or so you have maybe some pre-cooked examples which you can reuse, but still at the end it's a decision on this level. And of course, not all exposure models work like this. If you take a NatCat model, then it's a different approach. But this is, from me, if I look at this model here, one of the difficulties. How can I make sure that I have a coherent model which I apply for one profile, because the allocation of risks to one band or the other is kind of arbitrary. And also, if you have different portfolios from different clients, maybe they're structured in a different way, and you still want to be coherent. Yeah. So this is maybe an area where you can either predefine and with lookup tables or some other means to help you in this situation. Another approach would maybe be to use artificial intelligence to make these connections between the model and your profile. And I would be curious to see if you see any opportunity for artificial intelligence to support an underwriter in this constellation, because we probably have very little data where we can train it, and the number of possible cases is relatively large. So I think, in my gut feeling, it's not so easy to give this task artificial intelligence. But maybe you have some thoughts about this, because you come from a different angle, and maybe you can provide some input here.
Well, just first of all, I mean, regarding the general situation, I think you pretty much summarize it. And usually, I mean, especially in reinsurance, you have maybe 6-7 claims a year. And this is by far not enough to fit any sensible data. So I have actually written a book chapter a few years ago on how to fit copulas, and there it's even worse, right? So it's much easier still to fit distributions than to fit copulas. And for copulas, I could show that if you want to measure something which is normally the difference between two big numbers, right? Which is something like the result. It's a difference between two big numbers. And if you want to calibrate something like this, you would literally need millions of data points. And obviously you will never get millions of data points. So I think generally it's the more you can build some kind of physical model, the better. Now, obviously with generative AI, there comes a new trend. And if you had asked me 2 years ago, I would have said, don't do this, right? So you can, of course, generate artificial data, and you can fit on this data. And 2 years ago, I would have said, no way that this works and makes your stuff worse. So go and do classical models and try to do as best as possible develop physical models. But now we have actually companies that prove the opposite. For instance, DeepSeek, which is the LLM that was calibrated by the Chinese. We know that DeepSeek used a lot of artificially generated data to fit. And DeepSeek is extremely good. So this is kind of a proof, if you will, well, an anecdotal proof, if we will, that this approach can work. And like, you know, LLMs teach us a lot in terms of what's working, and we thought it would not work, and suddenly we see it works anyway. So yes, I would say definitely let's invest in this, let's see where we get to, and let's be surprised at what the LLMs can do for us in this space.
Mm-hmm. But as you see already by the color, the red color is a kind of intention, because it's kind of this entity relationship model which I reject. I want to move forward, and I want to make some modifications to it to make sure that it better fits into our context. So this is more or less what I call the conventional approach. I guess it's still what most of the reinsurance tools which are dealing with, let's say, man-made risks and so on, what they implement. Of course, in some areas, like I mentioned already, in NatCat, it's a different approach, but I think it's still commonly used. I'm not aware of anything different. So let's move on. So we elaborated on the advantages and the shortcomings, which I put here into documents, so whenever someone is interested, he or she can read it. But what I'm proposing in the next step is what I call a reversed exposure-based model. And you will see immediately why I call it reverse. So we just look at the upper part, and the bottom, it looks more or less the same. We have the claims and the development, so we are not really interested in this part. But let's look at the top. So we have here again our profile with the bands, but now between the model components, so frequency, severity, and development, there's an additional entity, which I call the market model. So we don't attach the model directly to the bands, but we do the opposite. We send the profile to a market model, and the market model then knows how to deal with this profile and the risks which are in there. So if I take the profile from one company or from another company, it will be treated the same or in a consistent way. And I can also make sure that in my market model that I treat the risks of different sizes in a consistent way. So for instance, I can define a parameter which depends on the size of the risk, and this parameter then determines the frequency or severity or whatever it is, so I can make my model coherent. That's the basic idea behind this. And then of course we have here, in this case, I say there is a one-to-many relationship, so the same market model I can use for different profiles. I can take the profile and can modify it, or I can take the profile from another company. So this is why we need this relationship. We'll see later that we will maybe replace this by a many-to-many relationship and what this means. But this is now the starting point. So here, that's also why I changed the color to blue, because it's already closer to what I want to do. Then if I generate claims, of course, it's the combination of the profile with the market model which defines my generative model. So it's a combination of the two. So for this generative model, I then have a claims profile, and the individual claims, they are linked, of course, they belong to this profile, but they are also linked to the individual bands. So this is where I can, if I need additional information, I know where it belongs. That's more or less the interim step. But as already mentioned, I want to calibrate my model. So this is one of the goals. And in here, we don't see the calibration is not yet there. And the calibration has to be somewhere between the profile, which is the idiosyncratic exposure information of a cedent, and the market model, which is generic for the whole market. So in between, we need this calibration. And maybe I also want to do something different. If I have this profile, maybe I want to run different models for different perils. Instead of using everything in one model, maybe I want to split it and say I have one model for fire, another is for burglary, another is for water damage in the house or whatever you want. So basically you can decompose it. And then I need to be able to connect multiple models to my profile. So I need a many-to-many relationship here. And this many-to-many relationship, of course, we need to resolve. And this is what we now see in the next chart. So which looks a little bit more complicated, so there's additional entities, but we will see at the end, maybe the entity relationship model has more entities and more connections and relations, but I think in using the model, it's easier than the first one. And what I have here, you can see this many-to-many relationship is resolved with what I call the calibration. So for each combination of market model and profile, for each of these combinations, you need one set of calibration parameters. And you can use the default. Let's say you define it and all the parameters are 0. There's no change. So you basically use the prior model without any modifications. But if you want to calibrate it, then the calibration parameters you put in here, and then it's applied to it becomes part of the generative model. What I've also added here, an additional entity, if I want to use, let's say, a separate model for each peril which I'm covering in my portfolio, then I can add it here and link it. But as you see here, it's not mandatory, so it's optional. So this is something which you can do here in this model, but really the relevant entity which connects the market and the profile is the calibration entity which I've up here.
It's quite a common approach in physics, right? So that if something is difficult to compute, for instance, we could do a Taylor expansion, right? So you take something which is easier to compute, and then you calculate deviations. So that's in a nutshell what you are doing here.
This is kind of what, at least I design my classes or entities, whatever it is, in a way so I have this flexibility. And here, I mean, there's also, you can then differentiate between different cases. Here it's optional. You could also say I make this mandatory depending on the use case. You could say you need to define this peril here. You could even say I have one set of calibrations for each of the perils, so they make a one-to-one relationship between the two. Basically, you merge these two entities. This is also possible. But these are the special cases of this general approach.
Well, there is another aspect I like a lot behind this type of model, and this is that normally it takes a few years of experience to understand where you are driving, right? Mm-hmm. And I think this is also a lesson learned that we had at Swiss Re with the underwriting steering values, that you cannot just, even if you notice that you are somewhat off in a calculation, you cannot just pull the steering wheel around, right? So you have to keep adjusting the steering wheel a little bit so that the passengers in the back don't get sick, right? And I think that's exactly where you need this kind of market model or this kind of more macroscopic model, because it gives you stability. It gives you a general sense of direction. You can learn, you can notice, oh, this year I was completely off. And then you can gradually take the steering wheel and adapt it a bit to the left or to the right, but never do too drastic movements, right?
And there's another aspect to it. This market model, you will not design during the renewal period. You will be off period. Yeah? So you can do it when you have time. You can analyze multiple portfolios. You come up with this market model. The same also with the calibration. And this calibration you can do anytime. And then the only thing you need to do is then during the renewal to plug in the new profile and to run it so you can focus on other things, interacting with the client and change the cover, whatever is necessary. But you don't have to fiddle around with tweaking some parameters in your model. So this is also an advantage. So you can really say, one is to understand the whole portfolio which I have in my books and then to come up with a kind of adequate model. And the other is then to go into the renewal where you have relative busy time and you focus only on what is necessary. So this is one of the additional freedoms you get if you use such an approach.
And to bring LLM into the game again, I think we need, if we want to use LLM, we have to really see where are they good at. And I think one of the really spotlights of LLMs is that I can say to which extent is this particular example in the average, or to which does it differ from the average, right? So this is where they are extremely good. And I think so if you have time to calibrate the average or the market or whatever you want, your entire portfolio that ideally you would renew, and then the specifics come in, and you just ask, is to which extent does the specific correspond to the average? I think that's where really the LLMs excel in this kind of task.
Okay, this is more or less what I wanted to introduce today. I mean, you see here, this is just some additional. When I said you have these different ways to link the calibration with the parallels, yeah, so I would put here 3 options, and if you put it into a class, then what does it mean? But this is kind of just emphasize what we already discussed before. Here also mentioned some pros and cons, so I think we have covered this thing, and I think the intention is that to kind of follow this model here when we start to implement our framework or the pricing and as I mentioned at the beginning, at the end we want to have all these boxes here filled so that we can run the model and calibrate it and then also use it for pricing purposes.
So I have a bit of provocative question for you at the end. To which extent do you think, or how far are we away from having the computer make a full suggestion for a pricing? I'm not saying take the human away, the human needs to be there. We all know LLMs, they hallucinate, they do creepy things. But how far are we away from saying, machine, create a pricing for me?
Well, I think the problem here is not being able to do it. The question is someone willing to accept the machine doing it? Because if someone is willing to use such an approach, I think we could do it within 1 year.
Yes.
This is more or less the timeline.
At the end, always a human has to look over it. But so still, in my opinion, it's a huge difference from I'm getting all this submission information, I have to kind of key it in somehow, I have to do everything manually, to the computer just comes with a suggestion, and I can either just wave it through, or I can go and adapt a little bit here and there. It's a huge difference.
And I mean, to get there, I think you need to do it in steps, right? So because the challenge is to come up with an adequate model here. We can also go down here. So this is the difficult part. And this market model, you need to do it for each market, for each line of business. So it really depends on the product. So it's not only implementing once, but you have to do many times. But I think if you decide to go, let's say, for a line of business where it's easy, where you have also enough information, then this could be done relatively quickly. So I would say implementation is a couple of months probably. And then you could maybe already start to use it in the next 1 renewals as a test, on a test basis, or run it in parallel. And then 1 year later you could go live with it. So this is the possible timeline, let's say. But of course you need someone who is willing to do it.
It's an absolute beautiful idea, right? Because you take away from the peak stress period, you take away workload, and you move the workload to the off-peak.
Right.
And it's exactly how to mediate such situations. Yeah. And I think it's part of the due diligence to study the market, so you'd better know which markets you want to enter. You should also know when you do the planning, which markets you enter. So you should have an opinion, what is a good market, what is a bad market, and how much you want to do. You need it also to compute the capital. You need to know the portfolio mix. So in my opinion, it's absolutely, if I owned a reinsurance company, it's absolutely where I would drive it. And so if you out there are keen to try it out, contact us on social media. Let us come to your company. Let us look into your book of business, both Stefan and I have multiple years of experience. We are very happy to help you digest this and see where could you apply such an approach.
Okay, I think we are done for today's lecture, right? If you are still here with us, don't forget to subscribe and to maybe send us your comments. So happy weaving and see you next time.